So welcome to everybody who's tuning in now to the web track of Nova Code Camp. We'll be talking about, or I'll be taking you through some live Kubernetes debugging with the Elasticsearch monitoring tools. My name is Emanuil, and I'm a community engineer for Elastic, which means that I basically go around and give talks like this, write blog posts, and just try to figure out what problems developers are having and how, well, we can solve them better. So connect community with company, I guess. So Kubernetes. I really like this quote from Charles Fitz. If Kubernetes is the answer, what was the question? So any Kubernetes talk that I give, I start with this, just as a reminder that just because Kubernetes exists doesn't mean that you have to use it. So sometimes you need to make sure that it really is the right tool for you, and that you're evaluating all your options. So if a virtual machine managed with some Ansible is really sufficient for the job and maintainable enough, then do that, because Kubernetes is a more complex platform. It's a complex orchestrator. It makes it a bit more difficult to access debugging and troubleshooting information. And so vendors like us try to bridge that gap, but there will always be a gap of complexity. So you're adding complexity to your stack pretty seriously with this. So I told you about myself. So imagine that you are a developer or an SRE, in fact, who is in charge of a small website. They're working for a small company, and the technology behind it is it's a Java app, so made using the Spring framework, running on Kubernetes. So you are, actually, I'll show you around the app. You are working for a small company that runs a veterinary clinic. This is the Petclinic Spring demo. So here we have the ability to look for owners, and we can edit information about owners. We can add pets for them. A list of pets, we have a list of doctors, and like any self-respecting demo, we have a way to generate an error. Now, so that's the app. That's what we're working with today. Imagine that. Actually, before we start imagining a problem, let's first talk about the architecture. So we've got this veterinary clinic website, and this is what we've chosen to build it on. It's running on Kubernetes, which means we've got a few Kubernetes services. Let's actually start from the back in this case. So in terms of data stores, we have a MySQL database and Elasticsearch, which I hear is a reasonably good data store. And in front of that, we have a couple of different services. So in front of MySQL, we have Java. And in front of Elasticsearch, we have a small Python service that runs some address finding for us. So the main backend is written in Java. And Nginx is in front of it to basically help moderate requests, search static assets, stuff like that. So we have these two services that are in the backend. And then in front of them, we have a front-end service. And that's using React, and that connects to Node.js. Okay, and we have various monitoring tools in place. So today, we will be focusing on FileBeat and MetricBeat, and you'll learn what those are in a second. And also code tracing. So today we'll be talking about logs, metrics, and code traces, and how to get them out of an app running on Kubernetes. Now, if you haven't heard of the Elastic Stack overall, this is at the heart of the stack. And by now, Elastic as a company offers tools in security, like even endpoint monitoring, like anti-malware stuff, enterprise search. And the main thing that kind of really was the first use case for our Elasticsearch open source project was observability. And so this stack here that you see is the observability bit of our products. Kibana is a graphical user interface we'll get to play with shortly. Elasticsearch is the open source analytics and search engine. Put text in it, put numbers, get them out quickly using many different kinds of queries and methods and aggregations. Then we have beats, and beats are like small, lightweight shippers written in Go that take some kind of data and put it into Elasticsearch. So you can then visualize it at Kibana. So today we're looking at FileBeat, which takes in either streams of log messages or just reads log files, hence the name FileBeat, and MetricBeat, which does the same for metrics like CPU, RAM, and that kind of thing. And Logstash is, we won't be looking at that today, but it's an open source project that's basically a very powerful log parsing engine, very configurable. There's tons of community modules added to it over time and a number of official ones. But it's a thing that can break down your logs from text lines into something with more structure that you can search more quickly, which we will see the advantage of soon. Okay, so let's get started with the demo itself. So imagine, again, that you're running this, you're responsible for this veterinary Petclinic website, but one day as you come into the office, somewhat groggy, it's like 8 a.m., and your boss traipses up to you and goes, I don't know, but we're getting reports of the site being super slow. Doctors are not able to access information. Owners are not able to access your accounts. Are not able to access their accounts. Everything is terrible. Fix it, please, ASAP. And so you waltz over to the coffee machine and you make yourself your morning coffee, and you sit down with a sigh at your computer, at your workstation, and you go in to the monitoring. So typically, where would you start? Great, apps have not loaded. Okay, I might have to wait a little bit. So when you ingest logs and metrics and code traces with the Elastic Stack and you use Kibana, you will see something like this. Right, there you go. So these are log messages that you're seeing here. So each one is broken down further into, so there's like actual information and there's the actual message. Oh, this is just an access log, so there's not that. Yeah, there's the actual message, but additionally, everything is further broken down, and we'll see how it does that. And notice there's things like Kubernetes prefix and the host prefix, so it's getting this information and enriching the log message. So clearly, it's reading an Nginx access log, but it's additionally getting a bunch of other information that makes it easier to navigate around. And sec. Okay, so we're gonna start with, so this is the first screen that you see. Now, if you've been using the Kibana for a while, you will probably want to start with metrics. Like the boss says, the thing is slow, right? Okay, so maybe there's not enough resources of some kind. So if we refresh the metrics here, so here what we see is currently just the hosts that Kubernetes is running on. Not refreshing. So we have 7 like bigger servers, and a couple of them running a bit hot on the CPU, but we also have 3 nodes that aren't doing that much. And we can also see memory usage, and that's all right, no big problems there. And we can see traffic and a log rate for each host and so on. Now, a more interesting thing probably is the Kubernetes view. Right, there we go. So this is the Kubernetes pods, all of them that we have running on our system, and it looks like we're running a multi-tenant system. So we have 250 pods nearly, and some of them are running, well, they're running a bit hotter, but we can see down here, in fact, I guess it would be wise for me to zoom in to make sure you can see. You can see down here that the maximum on this graph is 31%. So no pod is using more than 31% CPU. So, all right, that doesn't really seem to indicate a huge problem. Certainly not something that would explain the boss tearing out her hair. 20% memory use. All right. This just a bunch of squares, 250 squares. I mean, it's not the most useful display, is it? So you can additionally group by any tags you like. So you can group by the Kubernetes fields that you would usually have. So like a node, the host that the system's running on, service type, namespace, or you can group them by literally anything that's coming in, that is coming into those, that metric beat is consuming from those hosts and from those containers. Okay, so we're just going to do service type and namespace. So this is exactly as Lee was saying earlier, like it's hard to sometimes even get an idea of what's running. So this is a great way to just start exploring. Okay, so we have a bunch of service types and namespaces here. All right, so remember, we're just looking to remind ourselves what's running here. Okay, we got some kind of news service here. We got, looks like some kind of infrastructure stuff. We've got different applications. We've got an app called Cyclops. So this is clearly multi-tenanted, in case we had forgotten that before we drank our morning coffee. But the main point is none of it seems to be under huge memory load. And likewise for CPU. I mean, now further from that, okay, what can you do now? Well, if you pick a hot pod and go into it, you'll be able to see some more detailed metrics about that particular pod. Fiber internet, go!
I was laughing, but you didn't hear me.
Yeah, it's and this is why you should pre-open all of your demo tabs, which I had done, and then I had to change something. Okay. Oh. I mean, you are still, like, because I just heard Lee, so I'm assuming I am still online. Like, this isn't just me being disconnected. No. Huh. Oh, let's pick a different one. Like, I mean, it's a bunch of graphs on CPU and metrics. So, there we go. I like showing it because it's not that it's that complicated or that unique or interesting. It's just that once you've seen it, you get an idea of, okay, like I see the overview and then I get into the detail and this is what I get. This is important, I feel, for people to actually see something rather than just heard it described. So this is the kind of information that you would get from metric beat. And I'll also show you like the configs for how you would set this up in the Kubernetes cluster. So anyway, you have CPU, you have memory use, and none of it is looking too bad. You have network traffic as well. And if it had Nginx running on it, then you would get some further information about that. So anyway, that's us in metrics. Just bring my notes. Okay, so there's one final thing that I'd like you to see. Go back to metrics. So from the inventory tab here, we've seen hosts. So you can see survey your kingdom of Kubernetes. So you can see the hosts that the Kubernetes cluster is running on. You can see the pods, but you can also see individual Docker containers And that's useful if you're running, well, you can run multiple containers per pod, and that's maybe like arguable whether you should or shouldn't do that. But also useful if you're running Docker in other ways. So you can, this is especially in a migration scenario. So say you have a bunch of, I don't know, like Docker Swarm in production, why not? Or Docker Compose even in production, and you want to move away from that, understandably, to Kubernetes. So, but you know, that's not something you just snap your fingers and do, as much as many of us would like that. So in this case, this is what this allows you to do. So in addition to hosting Kubernetes, you also get visibility in individual Docker containers that are instrumented with metric beat. And you can do similar things here. So you can group by, so in this case, you could group by host to see where they're running. So only a couple of hosts they're running on, and let's say service type. So this just starts to give us some idea. Okay, yeah, we have this many of those kinds of containers, and yeah, okay, for on this host we have this many dedicated to Nginx, and if I switch the order around, so you do service type first and then host, and then I could look for a specific kind of service that I'm providing. So for example, look for Nginx. Okay, right. So I've got 7 Nginx pods running on 3 hosts. And those are them specifically. And from here, you can jump to the host. You can view the host's logs, metrics for an individual host, and so on and so forth. As I said, I just jumped to the overview for that host. That's like everything running on that host. So anyway, you could, we spend all day jumping between metrics here, but you get the idea. It's a way to explore what's actually running on your infrastructure. I think it's pretty useful. So how do we get data into this tab? Right, so I'll show you, I won't show you the whole, like setting it up from scratch, because I want to show you other ways of monitoring today as well. But I will show you the config that you need. And that will be the metric beat config, which is here. Okay, so the first and most important, yes.
Martin Shreen says, I think you're referring to Kali Linux. I don't even know if I'm pronouncing that right.
To Kali Linux, for which part, sir?
I don't know. There's a 20-second delay, so it was something you said 20 seconds ago. Sorry.
Okay. No. I mean, you could run this on any distro, but yeah, Kali for security discoverability, usually. That's what I hear it's used for. I always associate Kali Linux with adventure and danger. So, right. Auto-discover configuration for metric beat. So the way that this generally runs is you run metric beat in your Kubernetes cluster as one of the pods. And so you need a daemon set and a config map. And you can run it as part of a Elasticsearch deployment, or you just run a metric beat deployment, which is the example we have here. But so this is the configuration for metric beat itself. The most important part, also the easiest part, which is basically, this is where the vendor does a bunch of work to encapsulate some work for you, so you don't have to do it, is this auto-discover thing. So this tells metric beat to, provided that certain data sources are enabled, which I'll show you, to go away, release its tendrils and siphon off all of the info that you saw. There's certain conditions on like where it should get information from, like what pods it should get information from, and those are them. So those are called templates, and then this particular template says siphon metrics from pods that have a container name Nginx and that have this label for demo applied to them. And so for that, for those pods, you want to configure metric beat like this, to use the Nginx module to collect stuff, collect every 10 seconds, etc. Okay, and then we have a bunch of others to collect from MySQL and so on. So these are specific. These are not just CPU, RAM, and so on, but those are the specific metrics for those pieces of software, if they provide it, obviously. Then we have these processors. So add cloud metadata, Docker, and Kubernetes metadata. So here, we just want to go back to Firefox for a second. And so remember how there was like this stuff, cloud.think. Where's the host? Yeah, host.thing also, actually. That's something metric beat collects by default. Kubernetes.stuff. All of this, and I particularly find the cloud one quite useful, like it even collects stuff like machine type. So being able to see, in the individual log event, sorry, metrics event in this case, where it's running, it's great. So that, the way that gets collected is like this. You add these processors, and don't worry, there's a link to the files on the slides. In fact, there's quite a nice tutorial on Kubernetes and Elasticsearch on our main page on monitoring, and I've linked you to that. So you'll be able to play with all this yourselves. Okay, so what else? This is the stuff that you mostly saw in the UI. So that's CPU, load, network, information being collected. How does it get collected though? Okay, so you saw some pretty graphs. I said we configure metric beat to collect that stuff, but where does it get the information from? Well, here. So you tell it to add additional Docker metadata and also Kubernetes metadata in a similar manner. Now, the way that it actually does that, different file. So this is the configuration. This tells it, okay, use these data sources. So for example, let's pick one, let's not go too off track. Let's say use the Docker socket for information on Docker containers that are running. Okay, so you need to tell it that Docker metadata, and this is where you get it from. But metric beat, just running in a pod, doesn't have access to the host's Docker socket. So you need to give it access, unsurprisingly. And in order to do that, you need volumes. The volume mounts, and here they are. Yeah, that is pretty much it. So I guess the volume mounts is not so much an important thing as the volume itself, but same deal. Here is the volume. So we say, from that host, like mount var run docker sock and give, put it in the same place in each pod. And then in the config for metric beat here, we say, okay, in the pod, access that. And so that ends up accessing host Docker socket, and everybody's happy. We are pumping information. Okay, so, all right, so this is how you get some basic metrics, but that didn't really tell us where the problem is. By now, we have remembered what our infrastructure looks like, and we have probably drunk at least half the coffee cup. So what next? Well, we have logs. And what's the next thing you might do in this situation is you could look at your logs. So this is, in fact, let's start with this. That screen is already configured, how I think. So we're going to do something different. Okay, so let's set this to the go, where I cause an error to appear. Something we can just conspicuously look at that. All right, So let's have a look at the log exploration interface. With Kibana, first of all, you get the ability to autocomplete here. So there are a ton of things, and we wouldn't really know where to start. So let's say that I wanted to just look for some errors, and imagine we don't have code tracing. We only have metrics, so CPU and RAM and so on, and we have these logs. So usually when I was in this situation, when I ran a system, I'd look for errors, and then I'd get some context around the error with grep in the olden days of using grep. So in this case, I don't really know, but I guess it'd be called something like status code or response or something. So there is response code, definitely, yeah, HTTP response status code. Okay, net flow is a different thing. Okay, so yeah, that looks reasonable. Well, I guess I don't want normal situations, right? So let's look for over 400 in the date. Okay, that is significantly better than 3 million. I'll take that. So 14,000, there are a bit too many to look through manually. So let's have a look at what they are. Let's see if there's some way we can filter them further. Okay. There's a container name. Okay, that could be useful. There's a tag. Okay, this is the 404. We might want to exclude those. And type as Docker. Okay, so that looks reasonable. So we could exclude 404s. Probably should do that. And what do we have here? Okay, so again, this kind of error. All right, well, let's exclude 404s. And, ooh. Okay, so I want status code again. Pop. And we have equals a value. The tooltips tell me what I could do. What they don't say is how do I do a not. You know, they say equals. They don't say how to do not equals. So if I click here, it says it's using the Kibana query language. And if I open that, okay, this is some kind of tutorial on it. How do I do a negation? I want whole words. Clearly, whole words is very different. Aha. Terms can be inverted by prefixing them with not. All right, excellent. So I want that to equal. Come back. Yeah, I want that to equal 404, and I want to put a not in front of that. Oh, there you go. So it's almost like human language. Very far from human language. But okay, significantly less. Let's see what we got now. Okay, so this is an Nginx container, an Nginx access log. Right. I probably don't really want Nginx messages at the moment. Like I'm looking for application errors, please. So let's. Now, what was it again? That where it actually said Nginx. And there is the container name we could use. Let me filter it a bit more cleanly. Okay, yeah, so event module Nginx. So that's like the metric beat module that collected this event. All right, so we don't want anything collected by the metric beat module. So we're gonna say and not. Sorry, focus is shifting for some reason. I think this is because I'm zoomed in. Let me, yeah. Oh, there you go. I guess we've discovered that Kibana in certain situations is not that mobile friendly. And not event.module. And look at this. So this is interesting as well. It will even, besides auto-completing field names, it will actually autocomplete values for you as well. So these are all the possible values and the current filtered dataset for that field, which is pretty cool. So I don't want it to be Nginx. Search 27. Okay. Okay, that's a bit better. All right, so what have we got going on here? Let's open one. Yeah, it's actually, I guess let's open the first one. Put method, okay, that's a bit more promising. A 400 bad request coming from the client. Okay, that was fast. Not really saying that. Saying that much. I mean, it seems like we had an error, but it's not something that would be that difficult to diagnose, or that would cause sluggishness in the overall application. Oh, here's one though. Okay, so we have a put, a 400 again. It's a bad request, but the message says that it took 32 seconds to complete the request. All right, by now we know that, okay, we got these 27 and it's still kind of hard to look at them, but we know that they're all possibly important in some way. So what you can do is actually take out certain fields. So for example, let's first pick some descriptive stuff, like where it's happening. And this immediately collapses a bunch of it. Where it's happening, when it's happening. Is that my main timestamp field? Let's say this is a timestamp field. I want it. What else I want? Let's take the method and the code. Oh gosh, so much information here. Right there. Method and code and duration. All right. Ooh. All right, so we basically customized ourselves a little table here. That's what we've done. So this is a very useful feature. As you can just even if when you get to the point where you've narrowed it down, but now need to look at multiple attributes of a log message, that's how you can do it. So you got a post here, and that took like 10 seconds, and we have a bunch of fast bad requests, 400s. We have some that are like ridiculously slow. All right, so this is probably as far as we're going to be able to go with a log, because even if I open this and try to look for details, it doesn't really tell me anymore about what was causing this. It just, okay, the client, the React client, it just took a long time for the response to come from the backend to that. So, okay, that's all I know. And so why could this go sluggishness? This would capture my eye immediately, because sluggishness can be caused by just exhausting web workers if you're using just a standard model of synchronous web workers. Because if a worker is busy answering a request, then it can't answer any other requests. And so it could certainly, even if one route is being very slow, it could certainly have a huge impact. And you could, just for comparison, what you saw here, if we compare that to the raw log stream, right, there you go. So this is, I guess, the originally what the information would look like. That's like, you can search this in here actually. It supports searching by various fields. And you can just, it is Elasticsearch and the Elastic Stack. We've been doing logs almost since the company was founded. It's various tools that will help you, but it's still really hard. It's raw text data. So I am in huge favor of structured logging, which is what you saw. That's the result here. You can either break down a text log to produce this, which is what's happening here, or you can have your app produce its logs in JSON, and that's called structured logging, and I highly recommend it. So here's a very quick example for you in Python. Let's see if this comes up. Yeah, so I mean, this is obviously a very basic thing just for this logging framework, but with this, with struct log and its equivalents in other languages, you can essentially produce JSON. So the logs look kind of like this in their raw form, or you can make it output actual JSON. So I highly recommend doing this. I'm not going to spend that long on this. Highly recommend that approach if you haven't heard of it. Right, so, all right, we've gotten a little further with logs than we got with metrics. And you've seen the difference between using Discover and the raw log stream. So how do we get this information? We get it from FileBeat, which is collecting logs. Okay, so similarly to MetricBeat, the most important line where we've done most of the work, this is basically when you say .auto discover and they run it on Kubernetes and you say provider Kubernetes, that's where like all of our months, probably man years of, person years of effort come in. So then it goes off and siphons logs from the other pods that are running alongside it. Again, you've got templates and you can tell it, collect logs from pods which are tagged in this particular manner, or in this case, run a specific container. And here, collect the Nginx logs, please. Collect the MySQL logs, etc., etc., etc. And similarly, we have cloud host and Kubernetes metadata, which you saw. And these pipelines, FileBeat pipelines, allow it to parse stuff. So this is what converts the Nginx access logs into those fields that are separate fields you can search and autocomplete and do all that nice stuff with Kibana. So checking how we are on time. Oh gosh. Turns out when you actually run it, it takes a bit longer. Right, let's move on. So one important thing, that's the configuration for how it will siphon those files and what it will look for in terms of patterns to break them down. But how does it have access to those files? A pod does not usually have access to other pods, except if you give it access to varlib Docker containers. From then on, FileBeat knows to go in there in its local pod, which has the host, this host directory mounted in the same place. So essentially it spiders out to the host directory and it goes off and that looks for logs on its own. So that's pretty much how you set it up. Config map. So in the config map, important bit is these to tell it what to collect, and daemon set, very important bit, this thing. And the volume. They go together, so you get the idea. Right, so that's how you set up FileBeat, and that's how you get the stuff in Discover that you saw on the screen in your cluster. With metrics, we failed to really find anything. With logs, we found the clue that things were slow at some point, and that could be when people were complaining, I guess. boss might have told us a specific time when people are complaining, so we could use that to look for. But there is another tool that you can use in addition to these, and that is application performance monitoring, code tracing. So the way that you get to this thing is over here. It's called APM. As the other things we saw, this is called metrics, and underneath, this is the raw log stream that you saw. And at the top, discover is this log exploration or events exploration interface that I use to explore structured logs. And then finally out here, we have APM. Yeah, I thought I already asked. Ah, right. Okay. So APM, code tracing, we have all of our services instrumented. So APM is, if you haven't used a system like that before, it's something where you have an agent that either wraps around your app or hooks deep into it and gets things like how long transactions are running and it's kind of like an X-ray of your app, very in-depth metrics about your app and what functions are taking longer, what external calls are being made to other services, to other data, to data stores. And here we see all of them. So because we found the problem in React when we're looking at logs and the React layer, let's look at the React layer transactions. Okey-doke. So actually, let me just quickly open that anew for you, just so you can see how I managed to zoom into there. And yeah, of course, it keeps it in session state. So let's see. I want something like this, a longer time span. Okay, so you can see certain spikes, and that's usually super useful. This is how a lot of APM products look like. You can, so everything I'm showing you, and I should probably lead with that, but everything I'm showing you is free, by the way, that you don't have to pay for any of this stuff. And no trials, limits or anything. You can download all of the software and run it yourselves. Or run it on Elastic Cloud, which is what I'm showing you here. So we host it for you. But here, like even if you use other vendors, an APM system will look fairly similar to this. It'll have an overview of throughput and it'll have an overview of duration. 95th to 99th percentile are pretty important because see if I turn them off, it's like, well, yes, maybe a couple of spikes, but I mean, between 174 and 320 milliseconds, it's all right. But if I add in these, we're looking here for what we're sampling outlier transactions and giving them more weight so that, okay, what does this actually look like for a user? What does it feel like? And so I'm gonna zoom into the specific spike. Right, okay. So when you zoom into a potentially problematic period, you can get, like, it basically narrows down what you're looking at, so you get a clear look at the outliers. And so here we have something pretty outliery. Like generally it's taking like a third of a second to load pages, and it's taking 30 seconds, which is what that log message said. So the thing that's taking the longest, these are statistical averages, so it won't say 30 seconds here. The thing that's taking the longest is this one. So let's click it. It's a very similar view in the details. Here, these buckets are super useful because these are normal transactions on one side, 0 to 1 second. And then here we got slower and slower and slower. Here we got, okay, this is a problem taking 30 seconds. We'll click on it in a second, but let me first quickly chat to you about what we see here. So this is distributed tracing. If you haven't used an APM system, you basically just install the agents, the clients for each part. Like in this case, for React, that's in blue, for Node.js in cyan, and for purple, Java, Spring. And then you can trace the request as it makes its way through. It does that using, the front end will tack an HTTP header on it, and then the others will maintain the header. And so when all of it goes to Elasticsearch, then it will do a search and it'll pull it all together for you for that ID. So in fact, it does an aggregation actually, but same deal. So that's what an APM system looks like. And here you also even have specific queries, and you have exactly where they're issued from, and you have how long things are taking. And this is a normal transaction. So okay, like this Java function is taking the longest out of all of it, and it's also making a number of SQL calls, but they're microseconds, so they're really fast. All right, so that's great. But still hyper useful. Like this is a lot more info than a log, even a stack trace in a log would provide, because it also has timing. Then that's a problematic transaction around the time that people were complaining. Okay, so first off, no SQL queries. And what's taking the longest? So from the top, that's a cumulative count, so to speak. So the top one is taking so long because the one under is taking so long, because the one under is taking so long, you get the idea, until we come here. Validate zip code calls update owner, which takes less than a millisecond, but validate zip code takes 32 seconds. So that's what's slow. All right, so lines 12 and 33 of some kind of Java file. Great. Now, let's look at the error. Okay, so this is a lot more specific. We know exactly what's happened there, and you can, for speed, I think you can also see it here. Yes. So when you click a particular transaction, rather than like a SQL query, then it'll give you a ton of information about the environment, service, even Kubernetes info, like the host that's running on, container info. And also, if you've configured it to do that, APM to do that, then it will show you these. So that's the error. Right, so now we know what the error is. Updating owners, something to do with postcodes, and it says it's that particular one. Right, so if we very quickly, how is it this time already? If we very quickly try with that specific postcode, because it could be wrong, right? I mean, that could be a fluke. Okay, it's a React front-end, so it's gonna make an AJAX request, so I gotta watch that. Yep. Okay, that's taking quite a while. Basically, you can try this a few times, but in the interest of time, I'll tell you that it will do the same thing every time. All right, so what is the problem? Not that it necessarily matters from the point of view of an observability demo, but I know it's interesting because we're developers. All right, so there's the zip code validator file. That's what it's doing. So line 32 is over here. Okay, so this is calling for a match, which would then be evaluating to zip pattern matcher. Okay, we're calling this here. And in the end, it's using this pattern to do it. Okay, so it's still arguable that there could be other things in this code that would cause it to be slow, but this is the only substantial piece of code. Like the rest is just exception handling. So most likely it's this regex that's causing the problem. All right. So how did we instrument the React app to add APM to it? There's a lot more ways to do it than the auto-discover thing that I showed you with FileBeat and MetricBeat, but this is a way to do it if you're using React. You need to require the our real user monitoring agent. It's called Elastic RUM agent. You need to require it, and then you need to call init APM. That's it. You don't need all of these settings, just these three will do. Service name, server URL, because APM also has a server component, and that then processes the data, sends it to Elasticsearch, and we see pretty graphs. So you need a service name, a publicly accessible server URL, because this is client-side JavaScript. I guess version is not even required, so just name and URL. So that is it. And of course, you can see examples of this when you go to like the real user monitoring docs. The first thing you see is a quick start where you'll see all of this. Probably cleaner. Right. I think so. That is it. We discovered the problem. We saw it from the perspective of just looking at metrics and what they show us, looking at logs and what we see there, and looking at code traces. So there's just this, like regex. You might think it's a silly example, like, oh, regex is contrived. Yes, but it has been known to cause quite significant problems. So that happened to Cloudflare last year. So a spike on to 100% of machines worldwide by misconfigured regex or miswritten. And yeah, 82% drop in traffic. Yeah, so in conclusion, I'd say Kubernetes is more complex. And think about whether you really need it for your use case, because you are not Google and you are not Netflix, or maybe you are, in which case you do need it. But think about whether you really need it, and if there are other ways to get this information. You can do the exact same things I showed you in non-Kubernetes environments with the Elastic Stack, and it might be easier to diagnose and set up. But additionally, I feel like any kind of modern web monitoring system needs to have code tracing. I used to only use logs and metrics, even as recently as 2015. So if you are not using code tracing, like absolutely no shade for you, but I would really start using it. And given that the tooling I've shown you is completely free, and I doubt we're the only ones offering free tooling with this sort of stuff, you should go and have a look. Yeah, we help you map it all out. You'll get these in the slides. Can I go back? Because I'm pretty sure there will be questions a bit over time. There's a public demo of this stuff and all of the files. So the configs I showed you are that URL. Well, I'll paste them in Discord. Okay, right. So I'll just think slightly over.
No, you're good. Awesome. Well, thank you. Thank you, Emanuil.
Cheers.